Here's the super exciting stuff. Or basically the cover our ass stuff. Here's the basics, broken down. We think of vectors, they're kind of like a new number system almost, but it's not a number system, it's a whole different concept. But we gotta give it rules, just like adding and subtracting. Like you didn't learn it in first and second grade because it was too much for you, but there's some like basic, what we call axioms. Just basic rules we live by, like how we're allowed to do stuff. You know, like how in algebra we could do, like we can distribute the x in. Just little shit like that. Like what happens when we're messing with vectors like that? We gotta know all our rules. Like what are we allowed to do? So, hey, let's be real honest with you. If you're one of those students that doesn't really give a shit and you're like, just show me how to do the frickin' problem, switch to the next one. This one isn't for you. But those of y'all that want to have a good fundamental knowledge as to what's going on, maybe you just want to be exposed to it. Hey, keep watching. Let's get it. Go right past our component forms, our addition and subtraction, but here it is. How do we add, subtract, and multiply vectors? We just got these basic ass rules. So I'm gonna compare them with just numbers. So we won't write out all the vectors. I'll try and keep it pretty mellow so we can kind of see what's happening. But understand that I'm talking about a frickin' vector every time. So I'll give the comparison right here. We go into our first. And it's asking us about, is the u vector plus the v vector still the same thing as the v vector plus the u vector? It's asking us like, is 2 plus 3? Is that equal to 3 plus 2? And you're like, yeah, no shit, 5 equals 5. Well, same thing with vectors. It says, it doesn't really matter how you add them. It's commutative. You can turn that shit around. It makes no freaking difference whatsoever. So there's one. Let's go to number 2. Distributive property. Let's just move on. Come on. It's just saying it doesn't matter what those freaking parentheses are. It doesn't matter whether you add u with v, vector u with vector v, and then added to vector w. It doesn't matter if you would have added vector v to vector w first. It doesn't make any freaking difference what order we do this in. So that's what that one's saying. And now we get into this special one. Let's start talking. Since they're all bolded, that's saying they're a vector. Anything bolded is a vector. So that's 0. That's the 0 vector. And I've kind of glossed over it, not really talked about it too much. But the 0 vector just means that your components are 0, 0. You know what I mean? That it has a magnitude of 0. Has no length, no anything. Well, this is like in our, I'm using big quotes here. Like I'm in crazy hands up in the air with the quotes going. This is our 0 for numbers. It's not, it's called the 0 vector, which means it has no magnitude, but we need it. It's how we, 0 opens everything up in the number system. 0 opens everything up in the vector system as well. So we gotta have a 0 vector. Even though it's a stupid, silly thing, we gotta get it. So it's saying if you add nothing to a vector u, you will still have vector u. That's all it's saying. You gotta have the nothing vector, and that's what 0 is. Nothing's happening. Now the next one says, hey, if you add opposite vectors, like if you give me this vector, u, and then we turn around and we're like, oh, let's go back. Don't you just go back to where you freaking started, like you didn't go anywhere? Yeah, there we go. There's opposites. So when you add opposite vectors, you get back to the 0 vector, saying you didn't go anywhere. Like, hey, go get in your car and go to the store. And when you're done, go home. Where'd you end up? Right back where you freaking started. Moving on. Now we get into our, what's in bold as a vector, what's our C and that D, those are just freaking numbers. Those are, oh shit, no, we're dealing with vectors. We gotta be all like highfalutin. We're calling these scalars now, right? Sorry about the ticking of my dog's feet in the background. They like to wander around while I make these. So it's just saying it doesn't matter if you multiply the scalar by first, you just do this. C times D. There's D going into vector U. And then on the next one, you do C times D first. It doesn't matter what freaking order, because multiplication is commutative for the number system. And we already discussed that it's going to be commutative with addition, saying it's commutative with multiplication as well, with a scalar. We do not yet, we don't do this. This has a special meaning. It's called the dot product. It does not mean multiplication. We don't multiply vectors together. Even though you're going to see symbols that look like this. This is u crossed with v. Not multiplication. But we kind of think about it that way. It doesn't make any sense to multiply directions together. Moving on. Here's our distributive property. Right here. Boom, boom. It's like the vector u can just distribute right into any sort of constants, even though when you just add these two things freaking together first and they're constants, like 3 plus 5. I just call it shit 8. But just saying that the rules work. And then we can also say that if you're adding two freaking vectors together and you have some constant hanging out on the outside, just bring it on in. Right? Distributive property. It's just all the little bullshit rules. I bet this is just absolutely freaking fascinating for you. Here's our identity. If you just multiply 1 by the vector, it's still the freaking vector. Now this next one's a little trickier actually. 0, the number 0, not the 0 vector, that's just the 0, times a vector will give you the 0 vector. Not 0. But the 0 vector. All right. Ooh, what about those? What about those magnitudes? It's a beautiful thing about these magnitudes. You can just pull the constant right out from it. If you're gonna, this is gonna come in really handy later. Saying if you have some number, let's think about it from right to left. Say it's 7. That's the absolute value number. Just call it 7. And we bring it in and we say 7 times how long is vector v? Say vector v was 1 unit long and we're going to multiply it by 7. Isn't 1 times 7 equal to just the 7 that's over there? So saying you can actually break these pieces up. We're not going to talk about negative things. When we talk about links, we want to keep all that shit positive, and that's why that absolute value is hanging out on that constant sign. We're talking about length, let's keep that shit positive. All right, y'all, so I'm proud of you. You made it through. Our next thing we're going to mess around with is going to be our, what's called the unit vector, and we're going to dick around a lot with it. It's going to be super important. We're going to have to get into understanding this. But, hey, there's that's how we add, we subtract, we multiply. We don't really multiply vectors. We multiply by scalars. We don't multiply vectors with vectors. They have special names, different meanings. It doesn't have any logical piece to it. We'll talk about that crap later. Bang! See you later.